Good afternoon, everyone. Welcome back and welcome to a beautiful day today. Okay. Yes, Avni. Good afternoon, Nithishri, Ariharan, Hitesh, Anuj, Nancy. And yes, Anuj, happy Diwali to you too. Yes. Nithishri, I'm good. How are you? It's good to have you all back. And now let us talk about the topic in hand today. Topic in hand is the chapter on sets, relations, and functions. Okay. Now, can anybody tell me what do you mean by a set? Yes. Somebody can tell me what do you mean by a set? Can you put it in the chat box? When do we say? And I don't want a definition, okay? Whatever is given in the study material. When do we say that I have a set of things? When is that? Okay. I would like to know that. Yes. Anuj, Anjali, Akash, Anagha, Renuka, Surya, okay. Surya, Sunil, Humera, Manthan, Anil. Yes. Anil and Manthan, yes, very good. A group of like things, okay? Or it may be like things or a group of anything which has something that is connecting them, okay? When we say a cricket set, for example, what does it contain? A cricket set, it will contain things that are related to playing cricket, right? So that is a set of things. Or we have jewelry set. So what happens in that? The design of the earring, the necklace and all, they are going to be similar. Yes. Yes, Anuj. Set is a well-defined objects, is a collection of well-defined. Yes, that is what is the book version. But when I'm solving sums on set, relation, and function, what I have to remember is what is the common thing between all of them. Okay. Yes. Anagha, yes. Nityashri, collection of things. Yes, Priyanka, good afternoon. Anil saying group of keys, yes, okay. When we have a bundle of something, Anand, very nice. Adnan, good afternoon. Renuka, when there are more than one thing, yes. Then we say it's a set. Very good. Sunny, good afternoon. Sakshi, group of like things. Dheeraj, good afternoon. Surya. Surya is saying set is the well-defined objects or elements. A set is represented by a capital letter symbol and the number of elements in the finite set is represented as the cardinal number of the set in the curly bracket. Oh, thank you, Surya. You have made my job easier. Okay. And Ariharan, yes, set means a combination of things. Okay, very nice. So, basic concept is clear. Now, what we are doing is we are going into directly what it is. So, we are talking about the Cartesian product of sets. Okay, once we've understood what is a set, then we know how to count the number of elements in a set. Okay, so what we are talking about is Cartesian product of sets. For Cartesian set, I need to have two sets. Okay, A and B, and both should be non-empty set. Okay, non-empty means there must be some elements in it. Then the set of all ordered pairs A, B is small a means this element belongs to the set A and small b means this element belongs to the set B. Now this is an ordered pair, so that what is written on the left cannot be interchanged with what is written on the right. So A and B such that A belongs to A and B belongs to B. How is it written? It is written A belongs to A and B belongs to B. Is called as the Cartesian product of sets, product of A and B, to be denoted by A cross B. So how do I write a Cartesian set? A cross B. And what will be the elements of it? A comma B. Okay, where A is going to belong to the set A and B is an element which will belong to the set B. Then thus A cross B is AB such that A belongs to A and B belongs to B. How is it written? A cross B is equal to, you have pair AB such that, so this is representing such that small a belongs to capital A and small b belongs to capital B. So in this way, you can write what you want to talk about a set in a very concise form. Now, if A is 5, what is 5? 5 is a null set. Okay, or B is 5. Either of this is if 5, then A cross B is also equal to 5. Okay, like we have in number system, na, similarly it is. Like if I say a number is 2, 2 into 0 will be 0. And if I am saying 0 into 7, that will also be 0. So same thing it is saying here. This is important. If A is null and B is a null set, A is a null set or B is a null set, we define A cross B as 5. Okay. The illustration, let us take this illustration. Okay. So let us take this illustration, which is saying that suppose I have a set A. Set A consists of what? 1, 2, and 3. Then I have another set B, which consists of what? 4, 5. Okay. There is not this third line, there are only 2 lines. Okay. So B is such. Then we will define A cross B to be equal to, okay, now we are going to define A cross B to be equal to, what is the simplest way to do it so that you don't make a mistake is always take the first element of set A, complete it with all the elements of set B, then move to the second element of set A, complete with all the elements of set B, and so on. So now I have 1, 1, okay, I'm showing it for 1, 1, 4, and then I have 1, 5. Okay, these will be the two ordered pair. 1, 4 and 1, 5. Next will be, now this is over. B had only 2 elements that are finished. Now I'll start with 2. 2, 4, 2, 5. Then 3, 4 and 3, 5. Okay. So these are the ordered pairs that we have. So how many are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So we have 6. So otherwise it may happen that you are given this A cross B and then you are asked to find out the set A on the set B. So what will happen if this is given? Suppose this is given and I am asked to find out set A. Set A will consist of this 1. You know, in set you will write only once. So this is 1, I will write once. So 1. Then in this I can see 2 is common. 2. Here I see 3. So what are the first elements? I'm going to write an A. And whatever are the second elements, I will write in set B. So this is 4 and this is 5. What happens when I move to this term? Again, I've got a 4, which I've already taken. And so this is the case. Okay. So if I'm given 2 sets, I can find A cross B. If I'm given A cross B, I can find the 2 sets. Okay. Yes, Sania, good afternoon. Yes, I'm good. Kirti, Karan, Bipin, Vinod. Karan, लिया ना आपका नाम? Nityashri. I hope you can see this screen. It is always going to be that way, you know. Some part you can see me and the other part will be filled with the PPT. Not product, product. Sakshi, where I have written product? Product. Okay. ओके चिराग स्क्रीन ठीक से दिख नहीं रहा है बोल रहे हैं बच्चे ओके आई विल टॉक एंड लेट यू नो चिराग आर यू देयर सी द स्क्रीन इट सीम्स प्रॉपर्ली दे आर सेइंग फुल स्क्रीन नहीं दिख रहा मैम आधा ही दिख रहा है हाँ पीडीएफ हर बार वही रहती है हाँ श्योर नहीं जो हर बार मैं करती हूँ ना वैसे किया जस्ट लेट मी सी स्क्रीन शेयर is it visible now children left side of ppt not visible अब आ गया ओके ओके हाँ अभी दिख रहा है ना ओके थैंक यू सो मच हाँ हाँ yeah, yeah. See, where is it? Karan, this means belongs to. It is like E. Okay. Karan, this means belongs to. Okay. अनीश दिख रहा है शिवा हाँ शिवा बोल रहा क्लियर है हाँ नित्यश्री हो गया स्क्रीन का प्रॉब्लम सर प्रियंका या ओके सो this symbol like you have an E that means belongs to okay Akash I don't know how many students are pursuing CA foundation but it will be in lakhs of students okay then the most important concept in in sets is the De Morgan laws. Okay, now let us see. Let S, okay, this is the space 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how many number of elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, n of S, which is also called as sample space, is 10. Okay. Now, P, set P consists of 2, 0, 2, 4, 6, 8. Okay. And Q consists of 1, 2, 3, 4 and 5. Okay. So, this is the sample set. This is the space and this is P set and this is Q set. Then what they are asking us, find out P union Q. P union Q means you have to take all the elements that belong to P and Q. Okay. So, 0 I will take. Then here is 1. Whichever number is repeated, I will take it only once. Okay. So, which are the numbers repeated? This 2 is repeated and this 4 is repeated. So, I am going to take them only once. Okay. So, 0, 1, 2. Then I have a 3 here. Okay, I'm looking at AP as well as Q. Why that is so? So that I have everything in order. If you're not comfortable, you can write all the elements in P and then in Q, because as it is, this is an MCQ exam. So it will not make a difference. 0, 1, 2, 3, 4, 5, 4, 5, 6, and 8. So what is N of P union Q? This is equal to 1, 2, 3, 4, 5, 6, 7, 8. So N of P union Q is 8. So what is union? Which is considering all the elements in the set. Mania, Cartesian Bapasti? Yeah. Anuj, very good. Aishwarya, 0 रह गया है ना? हाँ, Anuj is saying it. Okay. Cartesian. See, what is Cartesian? You have two sets A and B, and then you find the product. So A cross B. Like we have numbers. Suppose my number is 5 and 6. Okay, so 5 into 6 is 30. Similarly, I have two sets A and B. So I will take the Cartesian product, and because I don't know what is in A and what is in B, I am going to write it as an ordered pair, in which the first element will always belong to set A and the second element will always belong to the set B. And so I have A cross B. Okay, Mania? Okay, Aishwarya, you heard it wrong. So now we will find P intersection Q. P intersection Q. Yes, Akanksha. P intersection Q means what? Which are the common elements in P as well as Q? Which are the common elements in P and Q? So if you have already done P union Q, you have already underlined those numbers which are repeated. And what this wants is those repeated numbers only. So which are the underlined? 2 and 4. So P intersection Q will be 2 and 4. Okay. So what is N of P intersection Q? This is equal to 2. Okay. Now let us see what is P dash and what is Q dash. P dash means what are the elements in the set S which are not present in P. Is 0 present? Yes. So I will not write it. 1 is not present. So I'll just say 1. Then 2 is already there. 3 is not there. 4 is already there. 5 is not there. 6 is there. 7 is not there. And 9 is not there. So P dash will be equal to 1, 3, 5, 7, 9. Okay. 1, 2, 3, 4, 5. N of P is equal to 5 and N of P dash is equal to 5. Okay. N of P is equal to 5, N of P dash is equal to 5. And what are the number of elements in S? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So N of P plus N of P dash is equal to N of S. So what is this? 5. N of P is 5. N of P dash is also 5. 5 plus 5 is equal to 10, which is equal to N of S. Okay. So what we have done now is we have found out P. We have been given P and Q, and I'm going to I found out P union Q and P intersection Q. Now I have found out P dash and Q dash. Okay. Okay. So now what I'm going to do is, where is my water? One second. Sorry about that. I forgot my water bottle. Okay. Then P, n of P dash and n of now Q dash. Let us find out Q dash. Q dash will be all elements in S which are not present in Q. So 0, it is not present. So I'll write down. Let me change the color. So this will be 0. Then 1 is there, 2 is there, 3 is there, 4 is there, and 5 is there. Okay, up till 1 to 5, it is already there in Q. So remaining 0, 6, 7, 8, and 9. So let us see. N of Q is how much? 5. N of Q dash is also 5. And so same thing like this. You have N of Q plus N of Q dash is equal to 10. Okay. Now, De Morgan's law. Okay, so now what we have done is we have been able to understand the basics of this thing. What is P? What is P dash? What is Q? What is Q dash? What do we mean by union? What do we mean by intersection? Okay, if you remember in the last time we talked about multiplication and addition rule. Okay, and permutation and combination. So this is similar to that. Okay. Yes, Kinjal, it is this chapter very similar to probability because what probability is based on this chapter. Okay, this is the founding blocks for the chapter on probability. Yes, Priyanka, yes, 2, 4, yes. बुक में है ये वैष्णवी स्टडी मटेरियल देखूं क्या? ठीक है, आपको बताती हूँ मैं बुक में कहाँ है. एक मिनट में बताती हूँ आपको पेज कहाँ पे है. देखिए 7.3 है, पेज नंबर 7.8 पे है. पेज नंबर 7.8. एक मैं दिखा दूं क्या आपको? Okay, so you can see it over here. Page 7.6, 7.7, 7.8. Okay, so here product of sets. You Cartesian product of sets is there, and then you have this, the product of sets A cross B also, and then you have this. Okay, and you can always refer to this thing, my PDF that I've already uploaded. So if you can follow it, and later on you can see where it is. Is that okay? डी मॉर्गन साक्षी उनका नाम है, जो मैथमेटिशियन है उनका नाम है. अच्छा अनुज, आपने 0 नहीं देखा? ओके. तांबेश्वरी, यस, थैंक यू तांबेश्वरी. 7.4 पेज नंबर पे है. हरिहरन, यस. हरिहरन में वेटेज आपको उसके बाद बताती हूँ, ब्रेक के बाद. It's given in this on the website also. Okay, because you know why I don't remember all this weightage thing is because I always feel I'm going to do well first, and only in the last month when I have to just make sure I'm doing very revision very well, that time I go in for weightage. Otherwise I don't bother about weightage when I'm studying, because sometimes a difficult chapter they will put a very small simple small sum, which just because I did not study, I may miss out. So I don't want that. I want each and every one mark to be in my kitty, right? So that is why. Okay, don't worry, I will tell you. Yes, Nitishri, understood clearly. Thank you. डी मॉर्गन कहाँ है बुक में? Sakshi, Tambeshwari, can you tell the page number? It is given. See, this is written. So it is noted that P union Q dash is equal to P dash intersection Q dash. Okay. This is, I think it is there on the page number 7.4. Okay. So now this brings us to the important law. The law says that if I have P union Q and I find its complement, this is equal to what? This is equal to, see, there are many ways to write this. This is 1 minus P of A union Q. Okay, this is the normal P plus P dash is equal to 1, that type. But what the law is saying is P union Q dash is equal to, just let me, thickness. Okay, P union Q dash is equal to P dash intersection Q dash. Okay, and P intersection Q dash is equal to P dash union Q dash. Okay. Now let us check. For P union Q dash, P union Q is how much? This. Okay. P union Q is this. So let me try to find out P union Q dash. So P union Q dash is all the elements in S which are not present in P union Q. 0, it is present. 1, it is present. 2, it is present. 3, 4, 5, 6, 7 and 9 are not present. So, P union Q dash is 7 and 9. Okay. This does not look a 9. Okay. So, it is 7 and 9. Now, let us find out on the RHS it is written, it is equal to P dash intersection Q dash. Where is my P dash? This is my P dash. Where is my Q dash? This is my Q dash. Which are the elements which are common in both P dash and Q dash? So, P dash intersection Q dash. Intersection means which is common in both. Is 1 over there? No. 3? No. 5? No. 7? Yes. So, I'll write 7. 9? Yes. So, 9. Okay. So, can you see P union Q dash is equal to 7, 9 and P dash intersection Q dash is also equal to 7, 9. Similarly, you can, as a homework, you can see P intersection Q dash which will be equal to P dash in union Q dash. Okay. Yes, Anuj is saying 7.5 page, Akash is saying 7.2. Okay, Vaishnavi? Hope you can see the thing. Because this is what I have taken directly from the textbook. This portion is there in the textbook. Okay. So, what does the De Morgan law further say that we are going to talk in terms of numbers. N of A union B is equal to N of A plus N of B minus N of A intersection B. Okay. This we know from here. You already know, we have done it in school also. N of A union B is equal to N of A plus N of B minus N of A intersection B. If A and B are disjoint set, okay, disjoint means what? Okay, disjoint means this. These are disjoint set. Means what? There is nothing, no element common between the two. Okay. So when this is there, what is happening here? This is A intersection B. Okay. This is A intersection B. But here what will happen? There will be no intersection. There is nothing that is overlapping. And so we say that if A and B are disjoint set, then this will be A intersection B will be 0. And so for disjoint set, N of A union B will be simply the addition of all the elements of in A plus those in B. Okay. Understood? Yes, Anuj. दृष्टि स्टैट्स अभी और 10 दिन के बाद शुरू होगा. Okay, so this is, and if you have 3 sets also same thing. Okay, same thing. For disjoint it is n of p plus n of q plus n of r. But if it is not just disjoint, if they are overlapping, then n of p union q union r will be n of p plus n of q plus n of r minus n of p intersection q minus n of q intersection r minus n of p intersection r plus p intersection q intersection r. Okay. So these are what you should know. Like this you can also get in theory, very easy marks to score. And as I keep telling you, don't have to mug up everything. All you need to do is try to understand, okay, why the n intersection n of a intersection b becomes 0 is because there are no common elements. In set, what is also important is the Venn diagrams. Drishti schedules are given month-wise, okay? So, right now you will find the schedule for January uploaded, February schedule will be uploaded end of the month, okay? Now, what is this? In this, you have A intersection B. So, you have A and B and they overlap. Okay, like, and this they are disjoint. In, for example, we say a class of boys and girls. So you can do not have common. Okay, so you have set of boys different and set of girls different. Okay, and when you have 3 sets, this is the way it looks. Okay, and the formula for that also we have done n of p plus n of q plus n of r minus n of p intersection q minus n of q intersection r minus n of p intersection r plus the common area. So let me show it to you. This green that I am coloring, this green color is P intersection Q intersection R. Okay. Now, this portion is the different P intersection Q, P intersection R, Q intersection R. And that time it will cover this also. Okay. So, this portion. So this you should be able to visualize, you should be able to represent, and you should be able to find out. Okay. Okay, Nitishri is saying schedule has already been uploaded. So just check. Okay, Drishti, maybe you missed it out. Okay. A survey shows that 74% of Indians like grapes, whereas 68% like bananas. What is the percentage of Indians which like both grapes and bananas? Okay. So this type of question, when there is not given in numbers but in percentage, what is convenient is let the number, this is n, of Indians be 100. Okay. Why I'm taking 100? Because the numbers are given in percentage. Okay. So let the number of Indians be 100. Then the number of grapes, Indians liking grapes is 74. The number of Indians liking bananas is 68. Okay. Now, this is my grapes and this is my bananas. Okay. Now what is happening is, why have I drawn this and not drawn like this? Is because here, what is the percentage of Indians who like both grapes and banana? Is there any sentence given in the question which suggests that there is nothing common? No, they have not given any exclusive sentence saying that no person likes grapes and bananas both. Okay, something like that if you have, then this will work. But since they have not mentioned anything, then, and it's a very straightforward question where they're asking you to find out Indians who like both grapes and bananas. So tell me, is it a question of union or is it a question of intersection? I'm asking, my question is this a question of intersection or is it of union? Okay, just let me know the answer so that I come to know how many of you are following. Okay, what do I have to find? Do I have to find A? Do I have to find G intersection B? Do I have to find G intersection B? Or do I have to find N of G union B? Yes, Nitishri, Surya, Vaishnavi, Nancy, Kinjal. Nancy, it is correct. This is a question of intersection. Kinjal, Anjali, it is not a question of union. It is a question of intersection because they're saying both. Okay. This means what? Both. Something is belonging to both. The grapes set also, people who like grapes also, and those who like bananas also. Okay, so this, therefore it is, the word used is both. Okay, and that is why it is an intersection. Yes, Sakshi, Aishwarya, intersection. Bipin, yes, correct. Aman, Anuj, Ariharan, yes. Surya, G intersection B. Kritika, okay, yes. Renuka, Akash, yes. Yes, Bhavesh, bhai. I think you forgot to write your name. It is G intersection B. So what do I have? N of grapes union bananas is equal to N of grapes plus N of bananas minus N of grapes intersection bananas. Okay. And this is what I have to find out. What is the percentage of Indians who like both? So I will take this to the other side. So I have N of G intersection B to be equal to N of G plus N of B minus N of G union B. Okay. N of G is how much? N of G is given to me as 74. 74% like grapes. N of bananas is 68, as 68 people like bananas, minus N of G union B. How many Indians are there? Total Indians is 100. So minus 100. So how much is this? Seven, 74 plus 68 minus 100. 42. Yes, Akash, very good. Akash, Anuj, Surya. Yes, actually, the name is showing only Bipin Singh. Okay. You can just write your name again. Okay. Next lecture. Anuj, correct. Priyanka, correct. Priyanka, where did this 60 come from? Okay, where did 76 and 60? We have 74 and 68. Okay, just check. Okay. Yes, Tameshwari, Avni, correct. Okay, now let us go to the next question. In a class of 60 students, 40 students like maths, 36 like science, 24 like both. Find the number of students who like maths only, science only, either maths or science, neither maths or nor science. Okay. Now what happens? You have a classroom. Okay. What is the class n? N of class is equal to 60. Now in the class, you have some students who like maths. So these are the math students. And what is the strength? 40 students. Then I have science. Then I have science. And how many for science? 36. Now what happens is, this common area are the students who like both maths and science. Okay. Common area like both maths and science. Okay. Now what happens here is, let me color the remaining area. This pink area that you can see is being colored by me, pink area is what? It is the number of students who don't like maths and science. Now some students do what? That they are confused. Now what to do? They will say, oh, otherwise I could use A union B complement is equal to 1 minus A union B. But that is not going to work here directly, because what is happening here is, I have got number of students who like maths. I have got somebody who likes science. There are some uh, students who are common. So let us see what I have. Okay. And this yellow, like both maths and science, is how many? 24. So n of maths union science is equal to n of maths plus n of science minus n of maths intersection science. This is going to give me, n of maths is how much? 40, right? This is 40 and this is 35. 40. N of science is 35. What are the common? Common is equal to how many? 24. Okay. So is equal to 24. So this is equal to 75 minus 24, which is equal to 49. Okay. Right? Let me check. 75 minus 24 is 49. Oh, 51. Oh, sorry. 51. Directly calculating the answers in my head. Okay. So, how many what does this 51 give? 51 gives me number of students. Okay. What this 51 represents? Number of students who like either maths or science or both. Okay, either like maths or science or both. Now I have the question, what am I asked? Maths only, science only, either maths or science, and neither maths nor science. So what this 51 is, it is giving me number 3. Okay, this is either maths or science. Number of students who like either maths or science or both, that is 51 is the number of students who like this. Science only will be, okay, maths only. Let us see. Maths only will be equal to how many like maths? 40. And what is the common? What is the yellow? Yellow is 24. So 40 minus 24, which is equal to 16. So maths only is 16. Okay. So can I color this? This is maths only. Science only. Science only is equal to 40. Not 40. How many are science? 36. Science only. अरे, pen क्यों नहीं आ रहा? Science only is 36 minus 24, which is equal to 12. So maths only is how much? 16. Science only is how much? 12. Either maths or science is how much? 51. Neither maths nor science. Okay. Neither maths nor science means what? What are the number of students who like either of them? That is 16 plus 14, 12 plus 24. Anjali, oh, 36. Oh, thank you, Anjali. That's what I said. Where am I going wrong? Okay, yes. This is 36. So this is 76 minus 24. And this will be 52. So this is 52. Okay. 40 minus 24, 18. Science. Remaining is correct. Yes. Okay. It's 36 का गड़बड़ होगी यहाँ 36 है. Okay. 36 line because I drew the pink on it, so I missed it out. Okay. Now they're asking neither maths nor science. What is the number of students who like either maths or science or both? Those I have found out to be how much? 52. What is the total number of students? 60. So neither maths nor science is equal to how much? 60 minus 52, which is equal to 8. So there are 8 students. There are 8 students who do not like maths or science. So how many maths are there? Total there are 40. Out of them only maths, how many like? This is 16. How many like only science? This is 12. How many like either maths or science? That is given to me as 24. How many students don't like either maths or science? Those are 8. Yes, Anuj, Aman, thank you. Hitesh, thank you. Anjali, thank you. Avni, thank you. Yes, Ariharan, it is 36. By mistake, I took 35. Nitishri, yes. Anuj, 36 science wala hai. Aishwarya, yes. Lipi Ray, see what happens if you're comfortable with the formula, fine. Okay. This can be done with the formula also. But for some students, it is easier to visualize. Okay. So that is why I'm giving you the visualization part. See, the formula part is already there in the study material. What additional can you learn from me is this. Okay. So sometimes it becomes complicated, there's some twist is given in the language. What I want you to be able to do is read the question and understand. Okay, you should be able to associate the symbol with the wordings. Okay, when I say intersection, what should it be? Either or neither. Okay, so those are the words I want you to understand. Yes, Kinjal. Yes, 12. हाँ सूर्या, either मैथ्स और साइंस 52 होगा. यस नित्यश्री. हाँ अब वो 52 हो गया, वो पहले गलत था ना. अब ये सही हो गया. 35 लिया था इसलिए 51 था, अब ये 52 है. यस. Yes, Avni. Avni has summarized all the answers. Yes, Anuj. Thank you that you like my teaching. Yes, Lipi. Thank you. Okay. If you are comfortable with the formula, most welcome. That is the easiest way out. But what happens is sometimes when like going from Hindi medium or vernacular medium to English CPT foundation, some of us like are not giving the Hindi version of CPT foundation. Then what happens is for us to be able to understand what the words mean. That is why I'm drawing. Okay, in this set relation, I draw more because what is given in the book is already there. You can easily understand if you put in the formula. But other than that, you should be able to understand. Okay. Now coming to relations and functions. Okay, I will be taking up as much as questions as possible, but since I'm allotted only one lecture for all the three sets, relation and functions, let us understand all the concepts quickly. Relations and functions. Okay, so relations establish connections. Relation establish what connections? Okay, this is very important between elements of two sets, while functions are a special type of relation. What are functions? They are a special type of relation wherein each element in the domain is mapped to a unique element. See what is domain, etc. We are going to study. Right now, what is important is while functions are a special type of relation where each element in the domain is mapped to a unique. So, what are the important points for function is that it is a special type of relation, and second, it is mapped to a unique element in the codomain. So, you have a domain and you have a codomain, and what is the mapping here is unique. Both concepts are essential in mathematics and have application in various real world scenario. Okay. In mathematics, relations and functions are fundamental concepts used to describe the relationship between set of elements. They are crucial in various fields such as algebra, calculus, and discrete mathematics. Okay. Why I have written this is because sometimes in theory question also comes. So for that you should be able to understand. They will give you a sentence, tell whether it is a relation, whether it is a function, none of these, both of these. Okay. So if they may say true or false, that saying that relation function is a special type of relation, or to confuse you they'll say function is a type of relation is a special type of function, or the other way around. Okay. So to be able to understand that, we will be doing this. Okay. Now we will see example of this. Let's consider two sets. A is this, B is this. So A is what? 1, 2, 3, 4. So you have 4 students with roll numbers 1, 2, 3, 4, and कृतिका मैथ्स और साइंस में बोथ इंक्लूडेड होगा या हाँ, वो उसमें आ जाता है। देखो बोथ में ना, जब हम बोथ बोलते हैं, कौन सा कलर लो, फ्लोरेसेंट लेते हैं। जब हम बोथ बोलते हैं, आइदर मैथ्स और साइंस, मतलब बोथ हो गया ना, उनमें से कोई भी एक होगा, तो ये पोर्शन आता है। ओके, इसमें दोनों आ गया। Okay, Dhanush, you had a bit confusion. Now it is clear, ma'am. From Chennai? Yes, Dhanush, welcome from Chennai. Sakshi, yes, I will explain what is domain and what is codomain. Okay, don't worry about that. First, let us understand what is a function, what is a relation, what is the connection between the two of them. Okay, this is okay, Kritika? Okay, so we are now talking about relation and function. We are saying that relation is a connection between elements of two sets. Okay, relation is a connection between elements of two sets. Okay, so and while function is a special type of relation where each element of the domain is mapped to a unique element in the codomain. Okay, so like we have, when I say, suppose I say Dhanush and Kritika are brothers and sisters. So what is the connection? That the connection is same set of parents. Okay, I know you're not real brothers and sisters. I'm just taking an example with two names. Okay, so what is there? The relation is what doing what? It is establishing a connection, है ना? आप लोग के घर में भी बोलते हैं, अरे वो रिश्तेदार है, उनके कुछ भी हो जाएगा, हमको उनको संभाल के चलना है, या उनकी बात मन पे नहीं लगानी है. Why? Because there is a connection and we will take it forward. We would like to take the relationship forward. Okay, but and the special case of relation is what? It is called as a function, wherein you are mapping each of them. So when we do the examples, it will be clearer. Just for the sake of understanding, you should know. Okay. Yes, Kritika, got it now? So we are considering set of two students. There are 4 students, A, B, C, 1, 2, 3, 4. And B is a set of subjects. Math, science, history, and English. Okay. So there are two sets. One is a set of students and one is a set of subjects. Now we can define a relation R between A and B, representing the subject each student is enrolled in. For example, the relationship can be expressed as R. Okay, so what I'm trying to do, I'm trying to establish a relationship R, wherein I take the first student, roll number 1. I see which subject is he studying. He's studying maths and science. Okay, so I'm saying 1 maths and 1 is also studying science. Okay, then I go to the next student. I see student number 2. Student number 2, I'm saying that he is studying English only. Okay, so he's studying English only. So I'm saying E English. Then I go to the third student. Third student is 3, roll number 3. He is studying science and history. So E is science and 3 history. Okay. And then I go to student number 4 and I say student number 4 is studying only maths. Okay. 1, 2, 3, 4, 5, 6. So this is the condition. Okay, this is the situation. Why? Because the student is given an option, he can do anything. Okay, so if I have a friend who is already done her class 12 and she wants to do English honors, so that student is going to take only English. Okay, suppose these are all optional subjects. ना इनमें से आजकल बहुत होता है ना स्कूल कॉलेजेस में, आप कोई भी सब्जेक्ट है ना, एक कई तो कंपलसरी सब्जेक्ट्स होते हैं, कई इलेक्टिव होते हैं. जैसे अभी हम लोग की सीए में भी हो गया है ना कि एक पेपर जो पेपर नंबर 6 होता है फाइनल्स में, वो जो है इलेक्टिव पेपर होता है, उसमें 5-6 सब्जेक्ट्स रहते हैं, उसमें से आपको एक लेना होता है. तो उसी हिसाब से कई तो कंपलसरी सब्जेक्ट्स होते हैं हमारे क्लास 12 में भी, और कई जो होते हैं ऑप्शनल होते हैं। इधर उन्होंने क्या बोला है, आपको ऑप्शन है, आप मैथ्स लो, साइंस लो, इंग्लिश लो या हिस्ट्री लो। तो कई बच्चों ने कैसे कैसे लिया है वो हम लोग ने यहाँ पे दिखाया। ओके, so in this example, one maths means what? Student roll number 1 is enrolled in the math subject. 3 history means student 3 is taking the history lectures and so on. Okay. So these are the relation. Yes. Now let us see what the function is. A function is a special type of relation that exists, that assigns. Okay. So this is important, that assigns each element from one set called as the domain to the exactly one element in another set called as codomain. In other words, for each input value, there exists a unique output. Okay, unique. You must remember whenever you are in doubt whether a given situation is a function or a relation, see whether it is unique. When it is unique, it is a function. Okay, so you have a set domain, you have a set codomain. And then when you try to map these elements, and like this is unique, so then we say this is a function. But if I have like something like this, then you say it is not a function. Or you can even have the situation. Okay. Okay. Then this is not a function. Is that clear? Okay. Yes. Let us take a break. Yeah. Let us take a break and come back and in 10 minutes time, and then do the remaining exciting sums. Okay. Can we take a break, Chirag? Welcome back. Welcome back after the break. Yes. Now let us consider. Consider the function f that maps each. Yeah. So here we started talking about what is relation and functions. And don't worry, we are going to talk about what is a domain, what is a codomain. Okay. Now consider the function f that maps each integer from a set of natural numbers in the domain to its square codomain. Okay. So I have a set of natural numbers and there that I call as domain. And in the codomain, what do I want? I want all the numbers which are squares. Okay. And n, is a set of natural numbers. So how do I show the function? F is going from n to n. So that I take the natural number and try to find its square which is within the natural number set. Okay. And what is my function? X square. So what is going to happen? See whether or not I have put in the questions. Yes, I have. Okay, don't worry. So suppose I consider f of 3. Okay, here f of x. So in place of x, I write 3. So what will be f of 3? This is x square. So 3 square. What is 3 square? It is 9. What will happen if I take f of 7? This will be 7 square, which is equal to 49. Is 9 a natural number? Yes. Is 49 a natural number? Yes. Then in the, what is the domain saying? Domain will be 1, 2, 3, 4, 5. Okay. Dot, dot, dot. And what will the codomain be? 1, 4. 1 square is 1, 2 square is 4, 3 square is 9, then 16, 25 and so on. Okay. Here, for every integer x in the domain, the function f will return its square as the output. Okay. Now, let us understand the properties and behavior of functions and relation in mathematics. Why is this? Okay. Mousepad is not behaving well today. Okay. Domain. So, you are asking those questions. What is a domain? Okay. So, now you can pay attention. Yes. Yes. So what is domain? The domain of a function or relation is a set of all input values for which the function or relation is defined. Okay. Means what is it? Domain. Domain is a set of inputs. Okay. Is a set of inputs for which the function is defined. In other words, the set of values on which the function or relation operates. The domain represents the x values in the function. So this is giving me the domain values. Okay. Consider the function fx is 2x. The domain for this function can be all real numbers since there is no restriction on the value of x. Okay. So in this question like we have, so domain will be the numbers on the x-axis. And will that be? It will be the inputs for whichever relation you have, what the input will be, that will be your domain. Okay. हाँ तो तंबेश्वरी बुक में 2x दिया है तो ये वाला भी कर सकते हैं ना जो रिलेशन है वो तो हम डिफाइन कर रहे हैं ना हमने x स्क्वायर किया 2x किया तो कोई प्रॉब्लम नहीं है अभी जैसे तंबेश्वरी बोल रही है एफ एक्स इज 2x so what will happen f of 1 will be equal to 2 into 1 which is equal to 2 f of 2 will be equal to 2 into 2 which is equal to 4 and so on right so in this case what will be the codomain codomain will be 2 4 6 8 10 etc Okay, this is your codomain. What will be your domain? Same thing. Number 1, 2, 3, 4, 5. So what is the domain? Domain is a set of all input values and it is represented on the x-axis. Is that clear? Now let us go to codomain. What is codomain? Is a set that contains all possible output values of a function. It represents a set of values to which the function or the relation can map its input values. It's worth noting that not all elements in the codomain need to be mapped onto the uh, from the domain. Okay, so therefore every domain member, every element in the domain will have a mapping in the codomain, but it may be possible that there are elements in the codomain which are not mapped. That is allowed. Okay, for you to have a function, what is going to happen is that for every element in the domain, you must have a mapping in the codomain, but you may have elements in the codomain which are not mapped. Okay. So what is codomain giving me? Codomain is giving me output values. What is domain giving me? Domain is giving me the input values. Okay. Now image. Okay. Nilesh, yes, your comments are visible. Yes, Anuj. Domain input value, codomain output value. Now, what is image? The image of an element in the domain is the result of applying the function of the relation to that specific input value. It represents the corresponding output value in the codomain. Okay, it represents the corresponding output value in the codomain. This is exactly what I'm telling you, that in the codomain, there will be elements which will not have a mapping in the domain. Okay. So when we talk of images, images are those elements which have a input in the domain. From there, it is coming to the codomain. Okay. So for the function fx is 3x, the image of the function of the number 5 would be 3 into 5, that is 50. So the image of 5 under the function fx is 50. Okay. We are showing the example, so you can see that. Mapping. Okay. The word is mapping. What we are doing is we have talked about domain, we have talked about codomain, we have talked about image, we are talking about mapping. A mapping refers to the process of associating elements of one set, usually the domain, to the elements of another set, that is the codomain. Okay, mapping means रास्ता एक नंबर से जो डोमेन में है और जो कोडोमेन में दूसरा नंबर है, उसका उस नंबर से उस नंबर तक पहुंचने के लिए एक रास्ता जो दिखाते हैं उसको मैपिंग बोलते हैं. ठीक है. So what we are showing is we are showing a road from the domain to the codomain for a specific element, that is mapping. Okay, and usually it is done from domain to codomain. This association is represented as a function or a relation. Okay, ये जो रास्ता है उसको हम function या relation बोलते हैं. जैसे हमारे पास अगर तीन स्टूडेंट्स हैं, like if I have 3 students, Alice, Bob and Carol, then the codomain is a set of the ages 18, 20, 22. What will happen? Can Alice be 18 years also and 20 years also? No, there will be a straight mapping, right? So usually how it is shown is, it will shown as Alice, Bob and Carol. These are the students, okay? The domain, this is the domain, okay? What will be the codomain? Codomain will be the set of ages. The set of ages is 18, 20 and 22. Okay. Now, Alice they are saying is 18, Bob is 20 and Carol is 22. Okay. So, this is mapping. When I want to find out age of Alice, I just have to see the map. Okay. Which direction the arrow is going, I will be able to find out. You can, in the set also, if you take the Cartesian product of set, where you have students set with age, okay, students and age, then you will have what? A 18, B 20, and C 22. Okay, is that clear? Yes, put it in the chat box whether or not you've understood what is mapping. We talked about domain. Domain is the set of input values and it is represented on the x-axis. Codomain is a set of um, the values which will be possible output values. Image will be the particular value for the function for the input from the domain into the codomain, and mapping is showing the road from the domain to the codomain, and it is going to point out towards the image. Pre-image. Okay. Now I know, suppose like I have this over here, just drawn it over here. So what I do is, from domain to codomain, this arrow that I'm showing you is the image. And when I say like this, okay, then I say the pre-image of 18 is A. We say that the pre-image of 18 is A. Okay. Pre-image of 20 is B. Pre-image of 22 is C. Okay. So what is pre-image? Pre-image refers to an element in the domain that gets mapped to a particular element in the codomain through the function or the relation. It is essentially the input value before the mapping occurs. Okay. So it is those values for which you have a image. Okay. These are the values for which you have an image. For example, let us consider the function fx is equal to x square. If you want to find the pre-image for the number 16, okay. So what I have 1, 2, 3, 4. And if I have 1, 9, 4, 16, then what I say, then I want to find out what is the pre-image of 16. I want to know whether this 16 has a pre-image. Yes, it has a pre-image. So what is the pre-image of 16? It is the number 4 in the domain. Okay. Yes, Anuj has understood, Nityashri has understood, Hitesh has understood, Kirti has understood. Yes. Yes, Manthan, it is pronounced as f of x. Okay. You can call it fx also, but f of x is the normal way to say it. Okay. So we talked about domain, we talked about codomain, we talked about image, we have talked about pre-image, and now we're going to talk about the range. Range is a subset of your codomain, okay, in which all the values which have a pre-image are there, okay. The range of a function is a set of all output values that the function can produce when taking all possible input values from the domain. Okay. In other words, it represents a set of y values associated with the function's domain. Okay. So codomain will have many values. Some of them will have a pre-image, some of them will not have a pre-image. When I take the collection of the values which have a pre-image in the domain, that will give me the range. Okay. Consider the function fx is 2x, where the domain is all real numbers. The range of the input would be also all real numbers, because any input value x will obtain a real image. Okay. So if I have all the real numbers, then what will happen? Suppose I have a which is equal to 5, 6, 7, 8, 9. Okay, like this. Then I will also have, and it is 2x. So this will be 10, 12, 14, 16. Okay. So this is also what? This is also a real number. So in this case, I have this as my range. Okay. So I have tried to show you here. Yes, Renuka understood? Yes, relation. So this is my domain. This is my codomain. These are my pre-images. So if 1 is mapped to A and 2 is mapped to B, then the image of A1 is A and image of 2 is B. And for A, the pre-image is 1. For B, the pre-image is 2. Okay. Then this is my relation, the whole function, the whole set, and function is a special subset of relation. Okay. So if I have A as 1, 2, 3 and B I have as 1, 4, 9, then what is this? This is the function is x square. So in this case, what is going to happen is this. Okay. So let me show it by an example. A is 1, 2, 3. Okay. Yeah. Let me do it this way. And B, suppose, is 1, 4, 5, 6, 9. Okay. Now, if I have the function, then if I have f is such that y is equal to x square. Okay. So, what are the elements I should take? Where x belongs to A. Okay. So, now what will happen is, what will be f of 1? X square. 1 square is 1. What will be f of 2? 2 square will be 4. What will be f of 3? 3 square will be 9. So I have those numbers over here. From B, I have 1, 4, 9. So that what is A? A is my domain. What is B? B is my codomain. What is my range? Range will be 1, 4, 9. Okay, range will be 1, 4, 9. What will be the image? Image of 1 will be 1, image of 2 will be 4, image of 3 will be 9. Okay, what will be the pre-image? Pre-image of 1 will be 1, pre-image of 4 will be 2, pre-image of 9 will be 3. Okay, so this is what it is represented over here. A is 1, 2, 3, B is 1, 4, 5, 6, 9, and then you have the function y is equal to x square. So A will be domain, B will be codomain, R will be the values that I get after applying the function. Yes. Very good, Anuj. Okay. So, you know what you should do? I've purposely put this like this. So, any question that you have, anything that you have, try to put it over here. Try to map it. No? Like in the Venn diagram also I have told you. Once you try to put it on the image, you will be able to find it. Hmm? Okay, what is it saying? Relation and function. Any subset of the product set X, Y is said to define a relation from X to Y, and any relation from X to Y in which no two different ordered pairs have the same first element is called as a function. Now, right now we have understood the concept. Now, let us try to put it in exactly what we have to do in terms of finding the, in terms of theory also. So, in which no two different ordered pairs have the same first element is called as a function. In which no two different ordered pairs have the same first element. So suppose I have like this. -1, 0, 1, and I have 0, 1. What happens is, and I have the function x square. 0 square will be 0. -1 square will be 1. Plus 1 square will also be 1. So, no two different order pairs have the same first element. Then what will happen? Okay. Then what happens is, I have to see how I should treat this. So, tell me whether this is a function or not. Yes, everybody? In which no two different ordered pairs have the same first element is called as a function. Tell me whether or not this is a function. Is this a function? So, you answer me, then I'll tell you the answer also. If A and B are two non-empty sets, then a rule or a correspondence F which is associating each element of X of A to unique element Fx of B is called as a function or the mapping. So how is it written? F is a function from A to B. Okay. B is called as the, all elements are called as the image, and in all elements are called as the pre-image. Okay. Okay, Kinjal is saying yes, it is a function. Aman is saying no, it is not a function. Hitesh is saying yes, a function. Nitishri is saying this is a relation and not a function. Okay. Let the others also answer. Now let us talk about some things are very interesting and important. One function, onto or surjective function, bijective function, and identity function. So let us start with this. Identity function is if A is an non-empty set, then identity function is A going from A to A. Okay. So this is identity. Okay. So function will be A going to A. Identity function is such that A is going to A. Okay. Now, one function. If different elements of A have different images in B, then F is said to be one or an injective mapping. Okay. If different elements of A have different elements of B. So, like in this case, I had 1, 2, 3, and I have this 1, 4, 9. This is what? This is a 1 function. So this is a 1 function. 1 square is 1, 2 square is 4, 3 square is 9. Okay. Different elements in A have different elements images in B. Onto or surjective function. If every element of in B has at least one pre-image in A, then F is said to be an onto function. See, what happens is sometimes students get confused between one and onto. Okay. और they feel कि कैसे याद रखेंगे ये सब. आपको ये याद रखना है जब हम onto की बात कर रहे हैं तो हम जो है हम कोडोमेन की तरफ से डोमेन की तरफ देख रहे हैं. आपको ऐसा समझना है कि आप कोड डोमेन में बैठे हो और आप डोमेन में झांक रहे हो और ये देखने की कोशिश कर रहे हो कि जितने एलिमेंट्स कोड डोमेन में हैं उनकी उनका इमेज प्री इमेज है क्या. हुँ? एक कभी होना चाहिए, एक से ज्यादा होगा तो भी चलेगा, लेकिन ऐसा ना हो कि मेरे पास कोई एलिमेंट है जो कोडोमेन में है और उसका इमेज नहीं है. ऐसा नहीं होना चाहिए. ओके. व्हाट इज द शिफ्ट इन visualization that you have to have in terms of onto is, for onto you have to think of yourself that you're sitting in the codomain. You have to think that you're sitting in the codomain, and your codomain should be such that every element in the codomain has at least one image in the domain. एक से ज्यादा होंगे तो भी चलेंगे. You may have more than one. So coming back here, can you tell me whether this is a one function or an onto function or both? Can you tell me this function that we have drawn over here, whether it is an onto function or a one function or what? Okay, so let me know. So till that time, let us go and see. And then we have bijective function. What is bijective function? A one and an onto function, so that every element in the domain has an image in the codomain, and every element in the codomain has at least one pre-image in the domain. Now let us consider the function a square of. So let us see a square of whether it is a into function, onto function, or bijective function. Yes, quickly. Dhanush is saying, onto function, ma'am, every element in the codomain has at least one preimage in the domain. Okay, let us check. Now, let the function be is square of. Okay, so now let us see what for every element in A, what will it be? F of 1 will be equal to 1. F of 2 will be equal to 4, isn't it? It's is square of. F of 3 is equal to 9. F of 4 is equal to 16. Now, A is this, B is 1, 4, 9, 16. 1, 4, 9, 16. So, what is happening? Here, what is happening? Okay. 1, 2, 3, 4. 1, 4, 9, 16. Okay. Now, what is the square of 1? 1. What is the square of 2? 4. What is the square of 3? 9. What is the square of 4? 16. Is it 1, 1? Let me check. What does 1, 1 say? 1, 1 says that if different elements of A have different images in B, okay, different elements of A have different elements in B, so this is a 1, 1 function. Okay, 1, 1 is there. Now, second, on to. If every element of B has at least one pre-image in A. Okay. See, now we are not going from A to B. Now I am sitting here. Okay. मैं यहाँ बैठी हूँ. मैं यहाँ से उधर देख रही हूँ. मैं यहाँ से उधर देख रही हूँ. मैं देख रही हूँ ए का प्री इमेज है क्या? हाँ, ए का प्री इमेज 1 है. 4 का प्री इमेज क्या है? 2. 9 का प्री इमेज क्या है? 3. 16 का प्री इमेज क्या है? 4. Does every element in the codomain have a pre-image in the domain? Yes. So this is also onto. What does bijective say? Bijective says that if I have something that is 1, 1 plus which is onto, it becomes bijective. So not only every element in my domain have an image in the codomain, but every image in the codomain has a pre-image in the domain. Therefore, this is a bijective. It is 1, 1, it is onto, and therefore it is bijective. अमन क्या एक्सप्लेन कर दूं? onto and 1, 1 again? Yes, Dhanush, it is onto every element in the tree. अमन आप देखिए क्या है कि मेरे पास 4 नंबर है, सपोज 1, 2, 3, 4. उसका मुझे स्क्वायर निकालना है, और स्क्वायर तो मेरे को आता है, 1 का स्क्वायर 1, 2 का स्क्वायर, उसमें कोई बड़ी बात नहीं. लेकिन मुझे वो मैप करना है, मतलब मुझे रास्ता देखना है. ए ए एक एलिमेंट, ए एक सेट है और बी एक सेट है. मुझे ए से बी जाना है. मतलब ए से बी जाने के लिए मुझे देखना है, अगर 1 का स्क्वायर मुझे दिखता है बी में, तो उसको मैं बोलती हूँ मैप कर सकती हूँ. और वो जो नंबर उधर आएगा बी में, उसको हम बोलेंगे इमेज. ए एक बड़ा सा सेट है, उसमें बहुत सारे नंबर है. बी एक बड़ा सा सेट है, उसमें बहुत सारे नंबर है. ठीक है. हमारे एग्जाम्पल में क्या है, ए में 4 नंबर है, बी में 4 नंबर है. तो ए और बी से, ए से जो बी में जा रहे हैं, वो रिलेशन क्या यूज कर रहे हैं हम उसको यूज कर रहे हैं स्क्वायर का. ठीक है. वो फंक्शन जो है इज स्क्वायर ऑफ, वो वाला ले रहे हैं. तो हमको देखना है कि वो कैसा है, वो 1, 1 फंक्शन है, वो ऑन टू फंक्शन है, या वो बाइजेक्टिव फंक्शन है, या अलग अलग नाम है. 1, 1 फंक्शन किसको बोलते हैं? जब मेरा जो ए में जो नंबर्स है, उसका जो स्क्वायर है वो सारे बी में मौजूद है. ठीक है. अगर आप ऐसा सोचिए कि अगर आपके पास ए ऐसा होता, 1, 2, 3, 4 और 5, लेकिन बी में तो इतना ही है, 1 4 9 16। तो इसमें क्या हो जाता है, ये जो 5 है ना, उसका इमेज दिखेगा क्या आपको बी में? उसका इमेज नहीं दिखेगा, क्योंकि बी में तो 25 नंबर ही नहीं है। तो उस समय हम क्या करेंगे, हम उसको बोलेंगे इट इज नॉट 1 1। ठीक है, सो दैट्स आई हैव टू सी, तो दैट इज 1 1। देन कमिंग टू ऑन टू, ऑन टू में क्या करना है, मुझे बी में बैठना है, बी से ए की तरफ देखना है। अभी तक क्या किया था मैंने, ए से बी की तरफ देखा था। 1 1 डिसाइड करने के लिए मैं ए में बैठी थी, ए से मैं दूरबीन से देख रही थी कि मेरे पास हर एलिमेंट का इमेज है क्या। बी में क्या करना है मुझे, ऑन्टो में क्या करना है, मुझे बी में बैठ के ए में देखना है कि मेरे पास जितने नंबर्स हैं बी में, उसका मैपिंग है क्या वहां पे, उसका प्री इमेज है क्या वहां पे ए में, वो मैं देखती हूँ। अगर मेरे पास ऐसा है कि मैं ए में बैठी हूँ तो मुझे इमेज दिख रहा है, और मैं बी में बैठी हूँ तो मुझे प्री इमेज दिख रहा है, एकदम क्लियर क्लियर दिख रहा है, तो उसको हम बाइजेक्टिव बोलते हैं। बाय माने दो, बाय माने अभी क्या हो गया, 1 1 भी है, ऑन टू भी है, इसलिए उसको बाइजेक्टिव बोलते हैं। ठीक है, आई होप यू अंडरस्टूड। नो, नॉट नेसेसरीली अनगा, इट्स नॉट नेसेसरी। Nee, Anjali, see what happens. You may have a 1 1 function. See, this is the very example I've given you. A and B, there is 1 1, right? Every element of A has a image in B, right? It is 1 1. But it is not onto. Why? Because every element of B does not have a pre-image in A. 1 1 और onto में वही problem है. 1 1 says what? If different elements in A have a different images in B. Okay? यहाँ तो हो गया, 1 2 3 4 को जो है वहां था, लेकिन यहाँ 5 अगर जब आता है तो नहीं होगा। लेकिन अगर मेरे पास ऐसा हो गया, सपोज इफ एवरी एलिमेंट ऑफ ए 1 2 3 4 and in B I have 1 4 9 16 and 25. Okay, this is not the case. Okay, so if I have something like this is 1 1, this is on 2. But if I have something like this, 1 2 3 4 and B has 1 4 9 16 25. Is it 1 1? Yes, because every element of A has an image in B. But it is not onto, because every element of B does not have one pre-image in A. Okay, is that clear? Yes, Aman? Yeah. And yes, I think Anaga and Anjali, you have understood? Then this is also a theory question. A function is invertible if and only if f is a 1 1 onto function. Okay. Then what is a constant function? Constant means in such a way all elements in A have the same image in B. Okay. So I have A, B, C. Okay. Okay. So suppose I have A, B, C and I have 1. A going to 1, B is also going to 1 and C is also going to 1. So then I say this is a constant function. Okay. Then what is into? We have talked about 1 1. We have talked about onto. Then we need to talk about what is an into function. 1 1, where every element of A has an image in B. Onto, where every element in B has a pre-image in A. And what is into? There exists even a single element in B having no pre-image in A, then its function is said to be into. This is an example of into. This is an example of into, where there is at least one image in B which does not have a pre-image in A. This ये जो 25 है ना, उसका प्री इमेज नहीं है. ये 25 है, उसका प्री इमेज नहीं है. 1 का 1 है, 4 का 2 है प्री इमेज, 9 का 3 है प्री इमेज, 16 का 4 है 16 का 4 है प्री इमेज, 25 को प्री इमेज नहीं है. ओके. इन्वर्टिबल मीन्स व्हाट? उल्टा कर सकते हैं. जैसे रेसिप्रोकल होता है ना, उस तरह से. जैसे हम अगर बोलते हैं reciprocal of 2 is 1/2. Okay, but if I have 0, can I find its reciprocal? It does not exist because 1/0 is infinite, or that is non-determinable. So we say that. Okay. Then equal function. Equal function, two functions f and g are equal and fx is equal to gx for all x. सेम फंक्शन होगा, उसका एक का नाम हमने f रख दिया, एक का नाम g रख दिया, तो उसको इक्वल हो जाएगा. इनवर्स फंक्शन, ये इन्वर्टिबिलिटी जो है ना, इनवर्स फंक्शन, जो अब इन नेक्स्ट चैप्टर में हम लोग जैसे लिमिट्स, और अब तो वो चैप्टर बहुत छोटा हो गया आपका, बट जो जो 12th साइंस मैथ्स किए हैं, या एटलीस्ट मैथ्स है जिनका, उनको मालूम है कि व्हेन कैन वी फाइंड लिमिट्स, व्हेन कैन वी फाइंड द डेरिवेटिव इंटीग्रेशन. सो उसमें ये बहुत इंपॉर्टेंट रखता है कि inverse function. If f is be an onto onto function from A to B, y be an arbitrary element of B, then f being onto, there exists an element x in A such that fx is equal to y. See, what you have to do is you have to remember this for theory. Okay, this slide particularly is there for theory. So I'm just revising this again. What is injective 1 1? I think I will have to change my mouse. An injective function is a type of function where every distinct element in the domain maps with a unique element in the codomain. So domain, unique, codomain. Okay, आपको याद रखने के लिए. Okay. For example, fx is equal to 2x is injective. So 1 1 का अलग से नाम भी क्या है? Injective. Then surjective. Surjective माने onto. A surjective function is a type of function where every element in the codomain has at least one pre-image in the domain. So I have the, here I have the codomain and it has a pre-image in the domain. Okay, at least one. And that is called as surjective also. Bijective means what? शिवा 10-15 मिनट और चलेगा क्लास. Okay, a function is called bijective. It is both injective and surjective. So this is equal to injective plus surjective is equal to bijective. Okay. Because I took a break because I was trying to fix this mouse, but it is not working still. Okay. So injective plus surjective is bijective. Then let us talk about a very important concept in this thing, which is called as different types of relations. So relations can be reflexive, it can be symmetric, and it can be transitive. Okay, relations can be, and when a relation is all three, that is, it is reflexive plus symmetric plus transitive, it is called as an equivalence relation. Okay, then it is called as an equivalence relation. Okay. Now, what does reflexive mean? I have a mirror in front of me. I see myself. So the image that I see in the mirror is my image. Okay. So reflexive. So any ordered pair of the form AA in S cross X. So I have a set S and I find S cross X. That is the Cartesian product of S with itself. Then all elements AA are reflexive because My image A and A. Can you make out this A is coming from this S and this A is coming from the other S? No. That is why it is called as reflexive. Now symmetric. If A, B can be means belongs to R and B, A also belongs to R, belongs to A, B belongs to R and B, A also belongs to R, such that A, B, which is belonging to R, then we put this type of arrow, which implies that BA also belongs to R. Then we say it is a symmetric function. Okay. If AB, the third is AB belongs to R, BC also belongs to R, and this implies that AC also belongs to R. This is the transitive. Transitive माने एक जगह से दूसरी जगह जाना. तो ए बी का रिलेशन है और बीसी का रिलेशन है. उसका मतलब एसी का भी रिलेशन है. उसको अगर हम प्रूव कर सकते हैं तो उसको हम ट्रांजिटिव बोलते हैं. Yes, Anuj, all these are different types of symmetric, different types of relations. Ambeshwari, what have you written? I did not get it. Reflexivity means each element must be related to itself. Okay. So, how is it written? For all x belonging to R, x R A. X R A, x R X is reflexivity. If x R Y, then y R X. That means what? This is symmetric. Okay. Then for all x, y, z belonging to A, x, r, y and y, r, z, then x, r, z. Okay. So x, r, y, r, z and x, r, z. Okay. X, r, then x, r, z. Now, suppose I draw an arrow from x to y. This is my x and this is my y. Okay. If the relation has to be reflexive, then I will draw a loop. Okay. So there is no start, no finish. So that means x going to y or y going to x will be the same. For symmetry, arrow is bidirectional. Okay. So I will have like this. For transitive, it will be a directed path. So x to y, y to z and x to z. Okay. So this will be transitive. Okay, Tambeshwari, by mistake written. Okay. When you have all three, you say it is an equivalence. So the famous example of parallel lines we take is one parallel line. Suppose this is AB, this is CD, and this is EF. First, symmetric. First, reflexive. Okay. AB is parallel to itself. Yes. Okay. That is true. A line will be parallel to itself. Second, whether it is symmetric, let us see. If I say AB is parallel to CD, does it imply CD is parallel to AB? Yes. दो लाइंस अगर पैरेलल है तो अगर हम बोलेंगे AB पैरेलल टू CD है तो CD ऑटोमेटिकली पैरेलल टू AB होगा. Third, okay, if I say AB is parallel to CD and CD is parallel to EF, does this imply AB is parallel to CD? We have done it in 8, 9, 10, right? AB is parallel to EF. If two lines are parallel, then if the third line is also parallel, then they become automatically parallel. That means AB is also parallel to EF. Yes. Okay, so this is the case. AB parallel to itself. Then AB is parallel to CD. So, and CD is also parallel to AB. So, therefore, you have the symmetric. And then AB is parallel to CD. CD is parallel to EF. That means AB is parallel to CF. EF means they are transitive also. So, when any the set of parallel lines is symmetric, transitive and reflective, it means it is an equivalence relation. Okay, so that's what we have done. What is equivalence? What are the examples? Equivalence of congruence triangle, equivalence of decimal and fractional representatives. These are other examples of equivalence. Now let us take an example is parents of. Okay. Is the relation parents, is it an equivalence relation? Let us try to understand. Reflexive. Okay. I have a set of parents. Okay. So reflexive. I am myself. Okay. I am myself. And so parents of A and parents of myself will be same. Okay. So I will have the same set of parents as myself. Okay. So always it will be reflexive. Then symmetric. If A has a set of parents XY and B also has a set of parents XY, then what will happen? Then you will have the same set of parents. A is also having parents XY, B is also having XY. So B, okay, if I say AB have set of parents XY, then BA will also have the same set of parents XY. अगर मैं बोलूं मेरे मम्मी डैडी और मेरे दीदी के मम्मी डैडी एक हैं, तो उल्टा अगर मैं बोलूं दीदी के मम्मी डैडी मेरे मम्मी डैडी एक है, फर्क होगा क्या? नहीं ना। मैं अपना नाम पहले लूं या दीदी का नाम पहले लूं, दोनों के पेरेंट्स तो सेम रहेंगे. लाइक if I say that Anuj and Dheeraj have parents XY, and then I say Dheeraj and Anuj have parents XY, are they same? Yes. So this is a symmetric relation. उससे फर्क नहीं पड़ेगा किसका नाम पहले ले ले, उससे फर्क नहीं पड़ेगा. So therefore it is symmetric. Reflexive means मैं और मेरी इमेज दोनों की पेरेंट्स एक ही है. Okay, so I am myself. So both of us have the same set of parents. So therefore it is symmetric. It is reflexive. Symmetric means I can take any sibling's name first, then also it will be the same. So it is symmetric. Transitive. अगर मैं बोलूं कि अनुज और धीरज के मम्मी डैडी XY हैं और ये बोलूं कि धीरज और किंजल के पेरेंट्स XY है, तो अनुज और किंजल के पेरेंट्स XY है, ये सही होगा ना? अगर मैं बोलूं ए और अनुज और धीरज भाई हैं, उनके पेरेंट्स XY है, फिर मैं बोलती हूँ धीरज और किंजल के पेरेंट्स भी XY है, तो इसका मतलब क्या हुआ कि अनुज और किंजल के भी पेरेंट्स XY है. सो दिस इज ऑल्सो ट्रांसिटिव. सो देयरफॉर इट इज एन इक्विवेलेंस रिलेशन. Okay. Yes, Anaga, understood? Okay, now let us see. Let us see this. These are examples from the book. I'll try to take as fast as possible. Actually, this one lecture becomes very difficult, you know. If A, X, Y, Z and B is PQRS, which of the relation which of the relation on A to B are function. Okay. Now can you see X, Y, Z, and this is P, Q, R, S. Okay, I'm trying to see for A, first option. X to P and X to Q. This is not a function, okay, because you must have unique. So this is not possible. Then X to S, X, Y, Z, P, Q, R, S. X to S, oh sorry. X to S, Y to S, and Z to S. Okay. Every element of X of this set A has a image in B, right? So this is a function. Okay. This is a function. See, Y to P, X, Y, Z, P, Q, R, S. Now what do I have? Y to P, Y to Q, Y to R, and Y to S. Again, this is not a function. Okay. Then X, Y, Z, P, Q, R, S. Now X to P, Y to R, and Z to S. Is this a function? Yes, because every element of A has an image in B. Okay. So this way you have these two are the okay. Next question. See, now when you have these type of questions, this is important for you to understand that put values. Don't look at it and see, because just looking at it, I won't know whether it's a function, it's a composite function, it's a one-one mapping, okay? That I won't be able to do. So what I have to do is first find out. Now what is the function? X plus y is equal to 5, where x and y belong to R, okay? So what will happen when x is 1? First is x is 1. Then y will be how much? Plus y is equal to 5. So y will be equal to 4. Then x is 2. 2 plus y is 5. Y will be equal to 3. X is 3. 3 plus y is equal to 5. Y will be equal to 2. Fourth. X is 4. 4 plus y is equal to 5. Y is equal to 1. Okay. So what is the ordered pair? 1, 4, 2, 3, 3, 2, and 4, 1. Can I map this? Okay. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is 1, 2, 3, 4. Okay. For 1, there is only this value 1. For 2, there is only this value 3. For 3, there is only this value 2. And for 4, there is only this value 1. So, is it 1, 1? Yes, it is 1, 1. Okay, you can do it this way, or you can like put it like this also. This is 1, 2, 3, 4, and I have 1, 2, 3, 4 here. Okay, so 1 will match with 4, 2 will match with 3, 3 will match with 2, and this 4 is going to match with 1. Okay, so this is how you should do it. Okay, similarly here also. Now x is equal to 4. Then what will happen? What will it be? This will look like this. What is it? X is equal to 4. And for this, I have this. the line is going to look like this. So this is on the x-axis and this is on the y-axis. Okay. Question 18, 7C, question 18. Just let me see. Just a minute. Manthan, 7C, question 18. Okay. Now tell me, for one value of x here, this is my value of x. No? This is x1, this is x2, this is x3. For one value of x, how many values of y can you see? This 1, this 2, this 3. What is the definition of function saying? Okay, can we say that? What is the definition? That functions are a special type of relation where each element in the domain is mapped to a unique element in the codomain. Every element in the domain is mapped to a unique element in the codomain. Is it unique? For every element in that x1 has 1, 2, 3. So this is not a function. Now here, what is happening? This is 1, 2, 3, 4, 5, 6. Now what will happen here? Is it unique? Yes. What will happen here? See, for x1, this point is also there, this point is also there, so this is not a function. Here also, for here, if these are overlapping. So for this value of x1, I can have this value of y1 as well as this value of y1 of y. Okay, this is y1, this is y2. For the same value of x1, I will have two values. So this is also not correct. Okay, so that is why this is not a function. So according to me, 18B should be the answer. Do we have the answer? 18B. 7C. 18B is the answer. Okay? Have you understood? Yes, Manthan, clear? Yes. I think we have run out of time. Next time also we have this concept of limit and all. And so if we finish that fast, we will take up some questions from here. Okay, I would like to take up more questions. But if I have, if I had speeded up here right now, you would not be able to answer. Then next we will also do f of g, g of f, all those exciting things we'll be doing. We'll also see whether some given functions relations are transitive or symmetric or not. Okay. Yes. Yes, Anuj, B he answer. Thank you so much. Yes. Thank you all for your patient hearing. Have a great day ahead and hope you enjoyed your this thing holiday today. Okay. Thank you all.